Software Implementation Lifecycle, and my name is James Kelly. Hi classmates, for my course project I researched the complete software development lifecycle, or SDLC. I see it as an IT version of Planned Parenthood. Throughout the semester I examined the 7 major phases. I'll explain what I learned from the course project, how each phase connects to the next, and how I used artificial intelligence as a resource and organizational tool throughout the process. I also walk through each phase. I'll point out where AI helped me and where I had to rely on course lectures, textbooks, and my own judgment to make sure the information was accurate. When I first saw this project, I honestly thought it was going to be about software development. By the end of the semester, I realized it was much more about project management than programming. The assignment focused on updating an existing information system, which is something information systems managers do constantly. Unlike creating a brand new system, updates have to fit into an environment where employees are already working, customers are already using the software, and the business can't simply stop while changes are being made, akin to working on a car while driving down the freeway. What really stood out for me was how interconnected the phases are. You can't skip ahead. If the requirements aren't clear, the design won't be accurate. If the design has flaws, development becomes much more difficult. Weak implementation creates more problems during testing. And if testing isn't thorough, development makes everything else much more risky. AI as a project assistant. How I used AI. I didn't use AI to replace research or writing the project for me. I treated it more like a junior project analyst. When I started researching the SDLC phase, different books and articles used slightly different terminology. Some combined activities while others split them into additional phases, and the artifact names weren't always consistent. AI helped me compare those different sources much faster than I could have done manually. It also helped me organize large amounts of information into logical categories. Once I identified the phases, AI could help me brainstorm common activities, identify supporting artifacts, and improve the overall organization of my papers. But this project also taught me the limitations of AI. AI can confidently present information that looks correct even when it doesn't match your course expectations. Because of that, every section had to be checked against the lectures, the assignment readings, and scholarly references before I could include them in my paper. This is probably my biggest takeaway about using AI professionally. It's an incredible productivity tool, but it's still the responsibility of the information systems manager, or me, to verify the accuracy and to make informed decisions. Requirements analysis. If I had to pick the phase that surprised me the most, it would probably be the requirements analysis. Before this class, I assumed the hardest part of software implementation was writing the code. After researching SDLC, I realized many projects actually fail long before developers ever start coding. Think about building a house. Imagine hiring a contractor without discussing how many bedrooms you need, whether you want a garage, or even what style of home you're building. Even if the construction crew does outstanding work, you'll probably end up with the wrong house. Software projects work the same way. Requirements analysis is really about making sure everyone agrees on the problem before anyone starts creating the solution. One thing I noticed while researching this phase is that's almost how every activity revolves around communications rather than technology. You're interviewing stakeholders, documenting business needs, validating expectations, prioritizing requirements, and making sure everyone agrees before moving in. I should have done this with my exes. AI helped me organize these activities into a logical sequence and identify common project artifacts like business requirement documents, requirements and traceability matrices. But determining whether these requirements actually support the organizational goal requires human judgment, something AI simply can't do on its own. Looking back, I think this phase sets the tone for the entire project. If you get the requirements right, every phase that follows becomes easier. If you get them wrong, you're essentially building the wrong solution very effectively, hence the X's. System design. Once the requirements are approved, the conversation changes. Instead of asking, what does the business need? The question becomes, how are we going to build it? That's what happens during the system design phase. Think of it as creating a blueprint before construction begins. Software teams shouldn't start development without designing the system first. That doesn't even sound good. This is where you're designing the system, the architecture, the databases, applications, security controls, identity management, testing strategy, and even deployment planning before any coding begins. This is another place where AI proved useful. It helped identify the types of design documents and organizations that are commonly produced. These architecture diagrams, entity relationship programs, interface specifications, and security documentation are all critical, and this is where they begin to be developed. But AI couldn't determine which design decisions were best for my specific application or organization. Those decisions depend and are based on business goals, security requirements, budgets, scalability, and the existing technology environment. To me, this phase highlights the difference between simply building software and engineering a solution that the organization can depend on for years. Implementation. When people hear the word implementation, they usually think of programmers sitting around in front of computers writing code. What I learned is that coding is only one part of the implementation. Before developers write or modify software, they prepare development environments, configuration tools, they pick their configuration tools, they establish version controls, and make sure everyone's working on the same approved design. One thing that really stood out to me in this phase is how disciplined modern software development has become. It's no longer about one programmer writing code independently. It's about collaboration, documentation, configuration management, and security integration, and the continuous quality checks that come later on in certain phases. AI helped me to understand how those activities fit together because it could quickly identify common implementation practices across different lifecycle models. Implementation represents the point where all of the planning finally becomes something tangible. The requirement becomes the software. The designs become the working system, and the project starts moving from ideas into reality. Testing. Testing is where everybody starts to get nervous, because this is where you start to see the results of what you've been working towards. At this point of the project, the software has been built. The obvious question becomes, how do we know it actually works? That's where the testing phase comes in. Before researching this project, I thought testing was mainly finding bugs. What I learned is that testing is really about reducing risk. Every type of testing answers a different question. Unit testing asks, does an individual component work? Integration testing asks, does it work with other components? System testing asks, does the entire application meet the business requirements? User acceptance testing. This one's huge because if the users don't like it, it doesn't matter. Will the people who actually use this system be satisfied with it? And of course, security testing asks perhaps the most important question of all. Can somebody exploit this system before we put it into production? AI was very helpful in organizing the different testing types because there are so many of them. There are a whole litany of testing. It helped me see how they fit together in one quality assurance process instead of thinking of them as separate activities. But understanding why organizations perform each type of test and how they reduce project risk came from studying the course material. Integration, and this is making everything work together. Modern organizations rarely rely on a single application. They have multiple systems. Their systems communicate with databases, cloud services, financial software, authentication systems, customer relationship systems, and countless APIs. The integration phase verifies that all of these are in sync and are moving along like the parts of an engine, making sure all the timing's right and things like that, and that communication is reliable. What interested me was how many integration problems aren't caused by bad programming. Instead, they're caused by assumptions. Maybe two applications expect data in different formats, or perhaps one system responds more slowly than another. Individually, everything works fine. Together, problems appear. AI helped identify common integration artifacts like interface control documents, API specifications, and release readiness checklists. That gave me a better appreciation for how much documentation is required just to ensure different technologies can communicate effectively. Integration represents the point where the collection of software components finally become an actual information system that can support the organization. Okay, deployment. Now this is where the rubber meets the road and where by the end of the month you'll be the most hated guy in the building. Because one of the things that I think is most misunderstood about SDLC is it's not about turning on a new application, it's about introducing change to an organization. And nobody likes change. It always is painful. Thousands of hours may have been invested in planning, testing, developing, and all that in the integration, but none of that matters if employees don't know how to use the updated software or if the transition disrupts normal business operations. It really irritates people when they can't do their jobs. That may sound strange, but organizations create rollback plans for deployment because they recognize that even well-tested systems can experience unexpected issues. Having a strategy to recover quickly is just as important as having a strategy to deploy successfully. Another important lesson was that deployment isn't just a technical activity, it's also a people activity. Training users, communicating changes, providing support, and managing expectations are just as important as installing the software itself, because if you don't get user buy-in, it'll be a catastrophe. AI helped me organize deployment activities, but the course reading emphasized that successful deployments depend on preparation, communication, and leadership that is just as important as the technical expertise. Maintenance and support. Now we had our baby, and now she's running free-spirited through the prairies like a wild young horse. Yes, now we have to maintain our big girl. Maintenance and support is the longest phase of the entire life cycle because the system now has to operate reliably for years. It is a living thing and has a life of its own now. Technology changes, business requirements change, security threats change, user expectations change. The system has to keep evolving. I found especially interesting was about the 4 different types of maintenance. You have corrective maintenance, which fixes problems, adaptive maintenance that responds to technical changes or technology changes. Perfective maintenance improves the performance and usability, and this should be constantly operating. Preventive maintenance attempts to stop failure problems before they occur. So this is why we're doing the maintenance and reading our logs to make sure that we're not going to run out of disk space or have bottlenecks in the routers, all kinds of things. AI helped me to organize all of these maintenance activities because there are dozens of operational documents involved. Well, lessons learned. If there's one thing the project taught me about AI, it's that it's neither a shortcut nor a replacement for expertise. AI helped me compare life cycle changes and different models, organize complex information, identify common project artifacts, and helped me improve the documentation and structure. And it explained technical concepts in clear languages, because once I looked up something, I could ask additional questions, and it just helped me dig deeper. I constantly compared AI's suggestions with the assigned readings and scholarly references. I did read some of the white papers. That process actually strengthened my understanding because I wasn't just accepting answers, I was evaluating them. And knowing how to use AI is good, but knowing when to question is better. Well, looking back on the project, I'm almost sad it's over. I realized that software development lifecycle is much more than a sequence of technical phases. SDLC progression helped me see why organizations invest so much time in documentation and project management. Those activities aren't paperwork, they're risk management. I finished the semester realizing AI is a resource assistant, brainstorming partner, and an organizational tool, provided it's used responsibly and its output is verified. Overall, the project gave me a much better understanding of what information systems managers actually do. They aren't just managing technology, they're managing the people, i.e. the users, the communications, the risks, the security, and continuous improvements throughout the entire life cycle of our baby. Well, thank you very much for your attention, and please comment, and I look forward to seeing you down the road in other courses.